we are a little behind between STAR and the cancel school from flooding. So, making a video, because we're going to move through this next lesson really quickly, so that way if you're confused, you can go back and watch this and get an idea of what's going on with the notes better. So, we worked on multiplication last time. This is going to be all about dividing. So, this is day 3 of our lesson 3. We are not only going to be going back to that simplifying with the domain and range, we are now doing dividing. So these will both come into play here when we're doing this. So key point, when we are dividing one rational expression by another, multiply the first rational expression by the reciprocal of the second rational expression. So rational expressions are closed under non-zero division. So what that basically means is you are not allowed to divide by 0. So that's why we're going to have those domain and range defined for these, because if we don't say, hey, it can't be divided by 0 here, then we're not actually doing this and keeping it equivalent as we go. So quick example here, this is that property that was in our key point, saying when you divide, you're actually multiplying by the reciprocal. So we take this, flip it upside down. So in this example, really what it's saying is we have 7 divided by x plus 1 times, well, the 2x minus 3 comes up top, and the x plus 2, that's now going to be down on the bottom. Boom. Now, simplifying it, be careful here, make sure you're saying, okay, this 7, technically there's parentheses here, it's going to distribute. So in our numerator, we'll have a 14x minus 21. Then in our denominator, what we need to do is actually our box method. So I'm just going to do that over here off to the side. It says, hey, we're going to have an x plus 1 times an x plus 2. So x squared, a plus x, a plus 2x, and a plus 2. So if I combined my two that are across from here, that are like terms, we'll end up with an x squared plus 3x plus 2. So this would be our simplified form here, because we always want to FOIL out and expand as much as possible. So for example 3, this is going to be our dividing here. So I'm going to zoom this out a little bit. There we go. Okay, so example A shows that we have a 7x divided by an x minus 2, divided by a 2x minus 10, can't talk today, divided by an x squared minus 6x, divided by an x squared minus 11x plus 30. So first thing is to take that reciprocal, like we did in our example. So we're going to say, okay, I have a 7x, that's divided by the 2x minus 10. Now we're multiplying instead. So we have that x squared minus 11x plus 30, and that's divided by an x squared minus 6x. So what I'm going to do here is I need to factor next. So we're going back to our multiplication rules. Okay, we did our reciprocal. Now we go back and say, okay, first step, we're factoring. Second step is going to be to cancel and multiply. Cancel / multiply. So when I'm factoring here, what helps too is to think about what can these things break down into. So this one's an x squared. There's nothing in common, so that one's going to have to factor with a t-chart. We'll do that over there in a second. But if I look at a 2x minus 10, I could think that as a 2x minus 2 times 5. So these both have a 2 here. So that means I can factor a 2 out. And this one I could think of as an x times x minus 6 times x. So they both have an x, which means I can factor that out here as well. So what that's going to look like down below is we'll have that 7x on top still, divided by the 2 comes out front, and the x and the 5 are what left behind, so x minus 5. Now this is times, I'm going to leave that numerator alone because I haven't factored it yet. But on the bottom, I'll also have an x times an x minus 6. Because if I take that x out and that one, that leaves x minus 6 behind. Now, factoring out that top function, you can either use your box method or t-chart. So we want something that multiplies to 30, but adds to negative 11. Well, negative 6 times negative 5, those give me the negative 11 that I need. So my factors here, x minus 6 times an x minus 5. So now that I factor this out entirely, what I'm going to do is I'm going to look for those like terms. So I see an x minus 5 and an x minus 5. They're on opposite parts of my fraction, one in the numerator, one in the denominator. Those two can cancel. Next I see 2x minus 6. These will cancel each other out. And I see an x and an x here. Those cancel out. So actually we're left with cannot write today. Left with 7 halves. Thing to be careful with here though is we still need to say, hey, what is that domain going to be? So I'm going to take each of those factors that I saw on the bottom and set them equal to 0. So I had an x minus 5, meaning if that's equal to 0, I have an x equal to 5 here. I also had just an x, so that just means I have x equals 0 as 1, and the x minus 6, that tells me, oh, x equals 6. So each of those will be a part of my domain. So I'm going to say, okay, x does not equal 5, x does not equal 6, and x does not equal 0. Or if you like your set builder notation, which I actually prefer for these, you would just put your bracket, x bar, and you'd say, hey, x does not equal 6, 5, and 0. End bar, or end bar, end bracket. So we have to do that for each one of these. Remember, you're always looking back at before you canceled out. What are each of these factors? Set them equal to 0. Now for b, we have our 6x squared plus x minus 15 divided by a 4x squared. But this time we're dividing by something that's not a fraction, so reciprocals get a little bit different looking. We have a 3x squared plus 5x. All we have to do here is pretend, hey, this is divided by 1. So when I find my reciprocal, I end up with a 6x squared plus x minus 15 divided by a 4x squared times 1 over 3x squared plus 5x. Alright, so the next thing, now that we've taken our reciprocal, is to find our factors. So on the top here, we're going to have to factor by grouping, everybody's favorite. So let's give us a little bit more space here. So our t-chart, typically we just do the last term, but it's actually technically multiplied by the first one. So 6 times a negative 15, that's actually going to be a negative 90. So we're saying, hey, what multiplies to 90 and adds to a positive 1? Well, luckily, this one's fairly easy to find. 10 times negative 9. Because if I have a 10 minus 9, that gets me a positive 1. But we don't just know our factors already here. We just know how we can break up this middle term. So first thing we'll do is we'll say, okay, we have a 6x squared plus, and instead of putting the x now, I'm going to put a plus 10x and a minus 9x. Now we bring in the minus 15. And this is all divided by our 4x squared. And I'm going to go ahead and factor this bottom part out as well. They each have an x in there that can come out. So times an x times a 3x plus 5. So hopefully when we do this, we actually end up with a 3x plus 5 so we can cancel some of our terms out here. So next thing is that grouping. So if I group these two and I group these two, remember there's always that plus sign in between. What I'm going to do is I'm going to say, hey, what can I divide each of these by? So if it helps, you can think about that breaking up of this. So I could do a 2 times 3 times x. Yeah, x got wonky. And then the 10, a 2 times 5 times x. So if I look here, they both have 2 and they both have x. So that's what I'm going to bring out front for that one. 2x. That will leave behind a 3 and an x. Plus that 5. Now I have a plus. This one I need to take out by factors here. So if it helps break it up, we have a negative 3 times x minus 3 times 5. So what we're going to do here is we're going to divide each of these by a negative 3. So we're going to have a negative 3 out front. Oh, the cat just did that. Negative 3 out front times, well, 3x plus 5 gets left behind again. So we've got our 4x, it's actually a cube now because we're combining those, times our 3x plus 5. Now, 3x plus 5 and 3x plus 5, I'm going to factor those out and they come up front. So what our next part of this equation is going to look like is a 2x minus 3. So I take each of these terms in the front and that becomes one factor. And what I see here, that 3x plus 5, that becomes my other factor. So we are going to be able to cancel those 3x plus 5s out. Boom, boom. So final answer is going to be a 2x minus 3 divided by a 4x cubed. And that should be everything. So, last thing, missing our domain. Domain. Remember, we have to go back to our factors here. So I can say if I take this x cubed instead of equal to 0, okay, well x cannot equal 0. And 3x plus 5, if I set that equal to 0, x cannot be equal to a negative 5/3. So if I wrote that in set builder notation, that would look like the set of all x such that x does not equal 0 or 5/3. So there is some practice to the right here. There's also some practice on the next page here. Now additional practice, remember that will be for stamps for points on the homework. Last thing we're going to go through is example 4. It is a real life problem. We have the total annual amount I in millions of dollars of personal income earned in Alabama and its annual population in millions can be modeled by the two equations here. So T represents the year, with T equals 1 corresponding to 2001. And they say, hey, find a model M for the annual per capita income. So per capita, all that's saying is, hey, per person. So then it wants us to estimate the income in 2010. So if 2001 is T equals 1, that means 2010 is going to be T equals 10. So our end goal is to be able to plug in 10 to an equation and find out the average income per person. So M is going to be saying, oh, hello kitten. So M is going to be saying, hey, what is the income I cannot write. Income, there we go, per person in Alabama. So, in terms of our equations, that's actually just equal to an I divided by P. But if I want it to look similar to our model problems, the way I'm going to write this is I divided by P. So here, if I write that out, it's going to be an M is equal to, it's going to get tedious, so work with me, 6, 9, 2, 2t plus 106,947. So that's my top part of my I divided by 0.0063t plus 1. Now I'm dividing this by p, so a 0.0343t plus a 4.432. So here I need to do my reciprocal. So once again, we're just copying this down, 6922t plus 106,947 divided by 0.0063t plus 1. Now this is times 1 over 0.0343t plus 4.432. So actually with this one, I'm going to just go ahead and leave it here. If you really wanted to, you could go through, multiply this all the way out. But I'm going to say, okay, this is my model function in terms of t. And I want to know what this is when I have 10 in for t. So what I'm going to do is I'm going to say, okay, I have 6,922 times 10 plus 100, I keep skipping one, 106,947 divided by a 0.0063 times 10 plus 1. Alright. And then we're going to do the 0.0343, that's going to be times 10 as well, plus 4.432. Yeah, I got kind of those letters there. Now, I am not going to make you do this by hand. Plug it into a calculator. If you want to try it on your own first, go ahead, pause this, take a second. Answer is 34,707. And this is dollars per person. Alright, there's the practice question. It's very similar. You're just looking at school expenditures compared to enrollment, so like what is estimated cost per student. Same process, different situation. Have fun. Oh, also, last thing, there's the kitten, the little turd that was shaking the camera earlier.